going to find them. And also sputum, tears, and all these cases. And immunoglobulin A is also a pentamer, as you can see here. 5 different monomers are come together and they are joined by disulfide linkages using a different region or different polypeptide segment, which is called a J chain. So whenever what kind of polymerization we are going to see, whether it's a dimer or pentamer or whatever, we must need another helper protein molecule to hold those monomers together using disulfide linkages, and those regions or those protein molecules are called J chain. So here in case of IgA we are having J chain, and also in case of IgM we are having J chain. Okay, so now let us talk about IgG. I have already talked about it, that the basic structure is similar: constant, heavy region, constant. uh, so two heavy chains, two light chains, both the chains are having constant and variable regions. So depending upon the, you can see here Ig1, 2 and 3 subclasses, and this is another subclass Ig3, which is having much the long kinked region here. It's also called hinge region or kink region. Okay, now it is a major, as I've told you before. It is the first it is the antibody. This is the only antibody which can transfer from throughout the placenta, right? So how it transfers through placenta? Because it transfer is mediated by the receptor on placental cells for the Fc region. So if we consider this is the receptor of the placental cell, here it is the IgG receptor, like that. Now IgG just go there and sit onto this receptor. As a result of this receptor binding, it will be internalized, right, like that. Okay, and this IgG can fix complement, because this complement fixation and all these stuffs are called the physiological activity or biological activity of immunoglobulins. Now this IgG is supposed to fix, and most of the time can fix complements, but also uh, not all subclasses fix complement. For example, IgG4 cannot fix complement. Okay, but rest of the IgG can. Now here we go for IgA. Now IgA is the second most common serum in serum immunoglobulin that we can find, and it is actually is a monomer, but it can form a dimer, and it can only form dimer when it is secreted. It can be found in secretions like tears, saliva, colostrum, mucus, and all these things. So normally IgA does not fix any complement. Most of the case it does not fix complement. Here you can see the dimerized structure of IgA. They are joined together. Two dimers are joined together using a J chain. Not only that, but we can see also a presence of another type of chain, as you can see, which is denoted here with this brown, with this dark reddish color. It is called another protein or peptide segment called the secretory component or secretory protein. Uh, Secretory component or secretory protein, or it is also called T component. Okay, T component and secretory component is a important part here, and which is also helping to hold these two different monomers of IgA together. Okay, now why this kind of J chain and the secretory components are attached to IgA? Usually IgA is a monomer, right? So let's say this is the plasma cell which secretes IgA. So here it comes, it secretes two IgA, suppose here, which both of them are monomers, and there are also small peptide molecules that are coming together, which are acting as a J chains that are surrounding all together. Now they first attach to this kind of J chains all together to make a slight dimerized form. Now this, along when they are attached to this J chain, they can be recognized and can be bound with a poly Ig receptor that are present onto the epithelial cell, which is ready for the secretion. Because when it need to be ready for the secretion, it must be attached and engulfed into these epithelial cells, which are the secretory cells. Now here comes the epithelial cells. Onto the surface of it we are having the poly Ig receptors. Onto this poly Ig receptor, the dimeric IgA starts to bind. As this dimeric IgA will bind to this poly Ig receptor, it will be internalized by the receptor mediated endocytosis process. Then enzymes will be released, and then it will be cleaved, and when they are cleaved from this basement, the whole system along with these two IgA molecules, J chain, as well as with this kind of poly Ig receptor, will come out, and they form a structure of dimer, like that. Now as they come out using this dimer structure, this poly Ig receptor that are present onto the surface of epithelial cells are converted, or are now being called as secretory component or T component. This is nothing but the receptor that was previously received the dimeric form of IgA. So what is IgM again? I have told you that it is having the pentameric structure. Again, they are linked via the disulfide linkages using another small short peptide fragment, which is called the J chain fragment.